Hello friends, welcome to H2 Abundant Academy. In the last lecture, we have started the discussion on the differential equation of first order. So what we have seen that the differential equation of first order has been classified under two heads. Equation of first order and first degree, and secondly we have equation of first order but not of first degree. Okay, so the equation of, so here we have the order is equal to 1 and degree is equal to 1. But here we have order is equal to 1 but degree is not equal to 1. Okay, so under this, that is equation of first order and first degree, we studied these many types, that is 6 types. And under this equation of first order but not of first degree, we study these many types. Okay, so in this particular lecture, we will discuss on this type 1, that is variable separable form. So let us start our discussion. Okay, so we have, if in an equation it is possible to get all the functions of x and dx to one side and all the functions of y and dy to other. Okay, so the variables are said to be separable. Okay, so this is our working rule. So we have, let us consider an equation like this: dy upon dx is equal to capital X times y. Okay, so where capital X is a function of x only and capital Y is a function of y only. Okay, so if we are able to represent this equation in this form such that the capital X comes with dx and capital Y comes with dy, so like this we can rearrange this. So 1 upon capital Y dy is equal to capital X times of dx. So this is nothing but variable separable form. Okay, so this can be easily integrated. Okay, so this is written here. So this is dy upon capital Y is equal to capital X times of dx. So this means variables are separated. So integrating both sides we can get this one. Okay, so this is our after integration we will get the result. Okay, so we have dy upon capital Y is equal to capital X times of dx plus c. Okay, so after solving this we will get the represent, and this is our arbitrary constant. Okay, so let us start solving the problems for ease of understanding. So we have, let us solve the example 1. Okay, so the first part is dy upon dx is equal to this one. So e to the power y we can take out. So this is e to the power x plus x square. Let us separate the variables. So e to the power y we have to write with dy, and dx, this term we have to write with dx. So let us take this. So e to the power minus y dy is equal to e to the power x plus x square times of dx. So let us integrate this. So we have minus of e to the power minus y is equal to e to the power x plus x cube upon 3. Integration of x square dx. So this is x cube upon 3 plus constant. So we have ex plus e to the power minus y plus x cube upon 3 plus c is equal to 0. This is the general solution. Let us discuss the second part. So we have this as dy upon dx is equal to e to the power x minus y plus e to the power 2 log x minus y. This we can write as e to the power x times of e to the power minus y plus e to the power 2 log x times of e to the power minus y. So we can take e to the power minus y common. So this is e to the power x plus this 2 log x we can write as log x square, log x square. So this is nothing but e to the power log of x square. So this is x square. So this is dy upon dx. So e to the power y dy is equal to e to the power x plus x square times of dx. Let us integrate this. So this is nothing but e to the power y is equal to e to the power x plus x cube by 3 plus c. So this we can further write as e to the power x plus e to the power minus e to the power y plus x cube upon 3 plus c is equal to 0. Let us discuss the third part. So we have y minus x dy upon dx is equal to ay square plus a dy upon dx. Okay, so this we can write as y times of y minus ay square is equal to a plus x dy upon dx. Okay, so this we can write as dx upon a plus x is equal to dy upon y 1 minus ay. Okay, so 1 upon y 1 minus ay, this we can write as 1 upon 1 minus ay minus this is a 1 upon y. This we can add this. So this is ay plus 1 minus ay. This gets cancelled. Okay. So this we can write like this. 1 upon y times of 1 minus ay. This we can represent this like this in a using partial fraction form. Okay. If we cross multiply this, so this is ay plus 1 minus ay. This gets cancelled. This is 1 upon this one. So let us place here. So this is equal to a upon 1 minus ay plus 1 upon y dy. Integration. Let us integrate this both sides. So this is log of a plus x is equal to 1 upon minus a times of a log of 1 minus ay plus log y plus log c. Okay. This gets cancelled. So we have log of a plus x plus log of 1 minus ay is equal to log of y plus log of c. Let us further simplify this. So we have this as log of a plus x times of 1 minus ay is equal to log of yc. So we have a plus x times of 1 minus ay is equal to yc. Okay, now let us discuss example 2. So we have this as, let us solve this. So we have sec square x tan y dx plus sec square y tan x dy is equal to 0. So this we can, let us separate the variables. So we have sec square x tan y dx is equal to minus of sec square y tan x dy. Okay, so we have sec square x dx upon tan x is equal to minus of sec square y dy upon tan y. Okay, so let us take tan x is equal to t and tan y is equal to u. So we have sec square x dx is equal to dt. So we have dt upon t is equal to minus of, so tan y is equal to u. So we have sec square y dy is equal to du, so minus du upon u. Let us integrate this. So we have log of t is equal to minus of log of u plus log of c. So log of t plus log of u is equal to log of c. So log of t times of u is equal to log of c. So we have t times of u is equal to c. So we have the value of t as tan x times of value of u is tan y. Tan x tan y is equal to c is the general solution. Okay, so let us discuss the part 2. Okay, so we have dy upon dx is equal to x times of 2 log x plus 1 upon sin y plus y cos y. Okay, so we have sin y plus y cos y times of dy is equal to 2x log x dx plus x dx. Let us integrate this. Okay, so we have sin y times of sin y dy integration plus y cos y dy integration plus 2 is equal to 2 x log x dx integration plus x dx. So this we have to use integration by parts. Okay, so this is nothing but minus cos y plus, let us integrate this by part, so y times of sin y minus integration d by dy of y. So this is 1 times of integration of cos y is sin y dy. Okay, so we have this as integration of sin y is minus cos y. So this is plus cos y is equal to 2 times of, let us integrate this. So let us take log x as first function and x as second function. So log x times of, this is x square by 2 minus integration. So d by dx of log x is 1 by x times of integration of x is x square upon 2 dx plus x square upon 2 plus c. So this gets cancelled. so we have this as this gets cancelled. So we have, let us further simplify this. So we have y sin y is equal to log, let us multiply this with 2. So this is log x times of x square minus, this is 2 gets cancelled, so this is x square by 2 x dx. Integration of x with respect to dx is x square by 2 plus x square by 2 plus c. This gets cancelled, so we have y sin y is equal to x square times of log x plus c. Okay, let us discuss the third part. So we have y minus x dy upon dx times of x is equal to y. Let us cross multiply this. So we have xy minus x square dy upon dx is equal to y. So we have this as xy minus y is equal to x square dy upon dx. So this is y common, x minus 1 is equal to x square dy upon dx. So we have this as x minus 1 dx upon x square is equal to dy upon y. So we have 1 upon x minus 1 upon x square dx is equal to dy upon y. Let us integrate this. So we have log of x and this is minus 1 by x square. So integration of this is minus 1 by x. So this is plus 1 by x is equal to log y plus log c. Okay. So this is the general solution. Now let us discuss part 4. So this is the, let us further simplify this. So we have 3 e to the power x tan y dx is equal to e to the power minus of 1 minus e to the power x sec square by dy. Okay, so 3 times of e to the power x dx upon 1 minus e to the power x is equal to sec square by dy upon tan y minus of, let us take this to the LHS side. So 3 times of e to the power x dx upon 1 minus e to the power x is equal to, sorry, plus sec square by dy upon tan y. Let us do the integration. Okay, so if 1 minus e to the power x is equal to t, so minus e to the power x dx is equal to dt. So e to the power x dx is equal to minus dt. So this is minus of dt upon t plus, let us take tan y is equal to u. So sec square y dy is equal to du. So plus du upon u integration is equal to c. So we have minus of log t plus log of u is equal to, let us take this as c1. So let us replace c1 with log of c. So this is nothing but log of u upon t is equal to log of c. So we have u upon t is equal to c. So this is the value of u is tan y. Tan y upon value of t is 1 minus e to the power x is equal to c. So tan y is equal to c times of 1 minus e to the power x. Okay, let us discuss example 3. How we can solve this? So we have, let us take x square common. So this is x square minus y dy plus y square 1 plus x dx is equal to 0. So we have 1 minus y dy upon y square plus 1 plus x upon x square dx is equal to 0. Okay, so let us further simplify this. So this is 1 upon y square minus 1 upon y, this is dy plus 1 upon x square plus 1 upon x dx is equal to 0. So let us integrate both sides. Okay, so let us integrate both the functions. Okay, this one and this one. So we have this as minus 1 by y plus sorry, minus 1 by pi. Integration of 1 upon y square is minus 1 by pi, and this is 1 by y dy, so this is minus log y. Minus 1 by x plus log of x is equal to 0. So this is sorry, is equal to c. So we have log x minus log y is equal to 1 by x plus 1 by y plus c. This is the general solution. Okay, let us discuss the part 2. So we have this as let us take x common here. So we have x 1 minus y square dx minus y 1 minus x square dy is equal to 0. So this we can write as x times of x dx upon this one 1 minus x square minus y dy upon 1 minus y square is equal to 0. Okay, so this we can integrate this. So we have this as 1 minus x square is equal to t. So we have minus 2x dx is equal to dt. So we have x dx is equal to minus 1 by 2 dt. So this is minus 1 by 2 log of, directly I am writing 1 minus x square. You can show this also. This is minus of minus, so this is plus 1 by 2 log of 1 minus y square is equal to log of c. Okay, so this is nothing but we can take to this side, this gets cancelled. So we have log of 1 minus y square upon 1 minus x square is equal to, let us take the c1. So this is not, so 2 log c1 we can replace with log c. So we have 1 minus y square is equal to c times of 1 minus x square. Okay, so we have discussed up to example 3. So we will discuss further questions in next particular lecture. Thank you.